What's the connection between a famous Scottish victory at Hampden, an article by a guy called Tom, a song by another guy called Tom, something to do with right-angled triangles that school students have been working on for hundreds of years, a theorem from the 1600s, and a book written by a maths teacher in Scotland who once had Scotland footballer Billy Gilmour in their school? It's all about connections. And I love connections. Not just in numbers and equations, but I love spotting connections in real life. And when I woke up this morning to read Tom English's report on last night's victory, I was delighted. I'll tell you why I was delighted. In it, Tom talks about how unlikely this victory was going to be for Scotland. We were struggling for long periods of that game, 60 minutes, and it didn't look good. Down 1-0 to Greece, who had been on top throughout the game. And yet something that's difficult to explain happened. Scotland won. And I like to think it had something to do with the fact that Billy Gilmour, who started on the bench, came on, and he was on the pitch as Scotland scored all 3 goals that then turned this from this unlikely scenario into a win. And Tom English in his article says, this is a head scratcher. This is something that I can't explain. And he says, this is like a few things, including, he says it's fiendishly difficult to explain, like Fermat's last theorem. Fermat's last theorem, that doesn't get a mention in the sports columns very often. So thanks, Tom English, for doing this. This is a perfect excuse for me to talk about Fermat's last theorem. And it's maybe not the theorem that everyone thinks about when they think about school. Quite often they'll think about Pythagoras' theorem, and they're linked. So you already know, if you've seen Pythagoras' theorem, that there's this thing with right-angled triangles. There's a connection with right-angled triangles where if one of the sides is A and one of the sides is B, A squared plus B squared equals C squared. And this is true for all right-angled triangles. We've known this way back. It's called Pythagoras' theorem. Like, there's another Greek connection, right? But we've known about these things for donkey's years. And actually, we've known about whole number solutions to this equation. So the most famous one is that if you take 3 squared and you take 4 squared, 3 squared's 9, 4 squared's 16. If you add them together, you get 25, which is 5 squared. And that isn't the only one that you can find. There's loads. You've got 5 squared and 12 squared equals 13 squared. You've even got 27 squared and 36 squared equals 45 squared. 27 squared is 729 and 36 squared is 1296. If you add them together, you get 2025. And 2025 is the same as 45 squared. And so, fast forward a wee bit in time and take us through to the 1600s to this guy Fermat that Tom English has mentioned in his article. Fermat's, he's not even a mathematician for a living. Fermat, he's a magistrate. He works in court. And one day in court, he's doing what he loves. He's doing a wee bit of recreational mathematics. And he's been thinking about this equation and wondering, what if you change these 2's to 3's? What about A cubed plus B cubed plus C cubed? Or what about changing them to 5's? Can we find whole number answers to that equation? What about if we change it to any number? What if it's 314 and A to the power of 314, B to the power of 314 and C to the power of 314? Can we find any integer solutions, any whole number answers? And so Fermat's last theorem is all about this. Can we find some numbers? So any number bigger than 2, we already know 2 works. Are there any numbers bigger than 2 for which A to the n plus B to the n equals C to the n? We'll have some solutions. And one day in court in the 1600s, Pierre de Fermat, he's maybe bored of whatever's happening in the courtroom that day, and he's doing some maths. And in his jotter, in his book, he writes that he's got an amazing proof that you're never gonna find any number bigger than 2, which is going to help satisfy this equation. And underneath that, he writes, I've got an amazing proof of this, but the margin's just too small to contain my proof. And so, Fermat, he dies, and somebody finds his book, and they're intrigued by the proof. And mathematicians for the next few hundred years try to wrestle with this thing. This is a theorem which is not that difficult to explain. We've done it in like 2 minutes, but it was fiendishly difficult to prove. And it took hundreds of years until the 1990s when a guy called Andrew Wiles, he's now Sir Andrew Wiles because of this, he eventually figured out a way to prove that Fermat was right. There are no other solutions. And Andrew Wiles had spent years, devoted years to try and solve this problem. And he emerges from his attic where he's been working on his own in isolation on this problem. And this is a massive breakthrough in mathematics. And his proof is so complicated that there's very few people on the planet can even understand it. And that wee story of Andrew Wiles, it inspires a guy called Tom Lehrer. And this is our second Tom. Tom Lehrer, he's an American mathematician, musician, satirist, and he writes a song called That's Mathematics. He wrote lots of brilliant songs, but this one's particularly special to me. He wrote a song called That's Mathematics. And in it, that song talks about this Fermat's last theorem. And during lockdown, we recreated Tom Lehrer's song. Me bashing away on the piano and famous mathsy faces singing lines. And so on that particular video, on our version of it, it begins with Countdown's Rachel Riley singing. Andrew Wiles gently smiles, does his thing, and voila. And then it goes over to Alex Bellos, who writes a wee article in The Guardian every fortnight. And he then goes on to say, QED, we agree, and we all shout hurrah. And then Simon Singh takes over and he says, as he confirms what Fermat jotted down in that margin, which could have done with some enlarging. And so that song came out during lockdown. It brought together a few of these things. And then it became a book, inspired by the lyrics of Tom Lehrer. But this book, That's Mathematics, by author Chris Smith, available in all good bookstores. And in it, it's the lyrics of Tom Lehrer, that song. And then it's got some wee puzzles and exercises from me. But all of this, it's about connections. Scotland won last night, yes. Someone hundreds of years after Fermat scribbles in his jotter solves a notoriously difficult problem. Yes. And then Tom English gives a wee throwaway line, an opportunity for a mathematician like me to get excited and to take this story into the classroom today and to share it once again that, you know what? Sometimes maths is hard, even for the smartest mathematicians. And there are things that we still don't know, things that we're still discovering, big questions that folk are still pursuing and chasing. Because maths is alive and it's exciting. And it's exciting like it was exciting to see Billy Gilmer and the rest of the Scottish team win 3-1 against Greece in a most unlikely scenario. Now we're on to Belarus on Sunday. Yes!